Good, how are you?
Good weekend?
That was alright.
Good.
I didn't get much accomplished, so.
Yeah, that's alright.
But we had to work 2 nights late last week, so
Yeah, that's true.
just trying to recover a bit. How was yours?
It was good. It was good.
Ours actually smooth. Transition pretty smoothly. It was actually easy.
Was it overtime?
You went 35 minutes?
Yeah. Nobody plays regular, so all of our parts were on. Like, we thought we were able to fit, but one guy made it was like, wouldn't clap on him.
No. What? Shoot, I do look like him. No.
Before realization.
No, I presented the next project today.
You presented your 20th project today? Nice.
Who were you?
Who was I or what was I? I was Gatsby, and our group was both the Renaissance and the arts. It didn't go terrible actually though. 'Cause all day yesterday from like 12 until 10 we worked on it on a FaceTime call, and then we finished it up. Except one person couldn't get on the call because they had something. So 3 out of 4 people were done.
Who would win?
Tyler and I.
John
Tyler,
Wilkes
you know
Booth
Tyler doesn't
or
win.
Gavrilo Princip?
So he and I were like,
Gavrilo
we
Princip.
had them all of the
Who's that again?
and then there was one person, like 2
Franz
people,
Ferdinand.
and then-
Oh, that's
It
a
actually
good one.
went
How good are you?
Not very good. I have to say, Gavrilo, like, I'm sure folks probably had to like sneak in a theater, but I mean, dude was just like sitting there the whole time. I'm sure like Archie Ferdinand was probably as more, you know?
Yeah, I mean, they stopped with the car. Like, it was just like,
Oh, and I had,
like local cafe. He saw that the coincident he went down this road.
you guys will
He was
love
taking a
this.
break.
I have
Wrong turn.
Not the solo.
So, he was
This
like,
isn't
I
even
don't know
mine.
if he
I
tried his
still
wife
look
too.
at because I left
I mean,
my
that's pretty Sigma, so,
I
gotta say. I gotta say, yeah.
And then
Princip.
I had Maddie also draw a picture for me to present.
Oh, right, and you look like.
It was good. It was good.
Looks like a trashy cop.
Partially.
Thank you, Diego. Thank you. I think I'll pull off the look pretty good.
They're like 2 days, 3 days
I've never
early.
seen Gatsby wear that.
Well, so
think
I
it's
had
underwear.
a blue, like a pastel blue. suit
No flamingo
jacket.
shirt, not base.
So I put that one.
Be based like
So it was
me, have
this was
flamingo
like highlights,
shirt.
and then you take my suit jacket.
Yeah, it was like, it's tropical, it's just plain, but.
I should get a shirt with this.
Kind of like a
Yeah.
prosthetic, like boat hole in the back of your head.
What do you mean prosthetic?
Let me just hold that in my head and then present my.
No, like one of those like backup.
Hey guys, this is
He can do back, just love it back of his head.
Alright, you guys will need a calculator, a new piece of paper, and a textbook today. So if you're missing any of that, please go get that sorted.
So we are now moving into the last part, the last section of logarithms, 3.4. Blake, y'all know you're dismissed at 1:45. Okay. You need to come over here. There's also a handout on that front desk you'll need a copy of. Go ahead and sit at this one today, please. Okay, so we are moving into the last section of logarithms. So all the log properties and set that we've been using, been building up towards this. So of course, working with logarithms and knowing the properties and all that kind of stuff can be beneficial in some of your science courses. If not current science courses, eventual science courses if you pursue a career in math or science. But to be honest with you, most of what we do with logarithms is really for this purpose of what we're going to see in section 3.4. So solving equations and using those properties for that. So number 94 was today's handout, so please number that accordingly. Okay, so through this we are going to discuss all of the things that you need to consider to be able to solve our equations. And I've got it kind of started off as easy as possible and then work its way up into what the book assignment's going to have you work up towards. But first off, you need to know with logarithms, what are they and what makes them unique. Specifically, they can solve exponential equations. So anytime you have an equation and your variable is in the exponent, if you want to solve for that exponent, you are going to have to know some of these logarithm properties. Okay, so the easiest thing, but there's a couple of these in your book assignment. Sometimes you can just do these in your head. So of course, if that's the case, don't make the questions harder than they have to be. So 5 to what power gives us 25? 2 to what power gives us 16? Okay, and then even if it's a logarithm, if it's one that we can do in our head, this is asking 2 to what power gives you 8?
3.
And then 3 to what power gives you 9?
2.
Okay, so we've been practicing that stuff for a while. So if a question is that straightforward, then of course just do it in your head and move on. You don't make it harder than it needs to be. But by far, the most common way that we will be solving these equations in this section is going from exponential form to logarithmic form. Caroline, you need to put your computer up. Now it's not the time for that. So if it's in exponential form, we've talked about what it looks like to go to logarithmic form. Put log out front and switch the two correct things together. And then if you have x equals, it's been solved. So logarithmic form look like this. And then what would this one look like in logarithmic form?
Base 17.
Log base 5.
Yeah, log base 5.
7.
Equals x. So sometimes just switching it from exponential form to logarithmic form is enough. If it gets you down to x equals, then great. Do it, circle your answer, and move on. Now we've got the same 3 questions over here for me to show you a different strategy. And to be honest with you, I think this strategy on the left is better, but sometimes this strategy is necessary. Depending on the question, sometimes you have to do this, okay? So you need to know that sometimes you might want to take the log or the natural log of both sides of the equation, your choice. Because then what happens on the left? What can I do with this stuff?
That makes it X.
Okay, why does it become x?
Kind of what Kate was trying to say. It makes up the one the X would be X.
Okay, so the exponent can come down. I'm not asking for the answer. I want y'all to say why it works that way. X is an exponent on something we're taking the log of, so the x can come down out front. Natural log of e is just 1, because this is saying e to what power gives you e. So, do you see how we get the same answer as number 6 with a different approach? Same thing. Base e means natural log. And, or, you might just take the log of both sides Doesn't have to be natural log. So that if x is an exponent on something you're taking the log of, the x can come down out front. And then undo times with divide. Now, is that the same thing as this one? Log of 3 over log of 10, is that the same thing as log base 10 of 3?
No.
Yeah. Because log of 10 is really just 1, right? So you end up with log of 3, log of 3. So. Okay, and then one more. Take the log of both sides. That makes the thing you're solving for an exponent on what you're trying to solve for, so it can come down out front, and then you can undo times with divide. Now, I would like to know, why is this answer the same as this answer? How are you supposed to know those two are the same? Very good. If you know change of base, this, if you wanted to type this in your calculator, this would be how you would do it. So I just want you to see different answer, or same answers, they may look slightly different, different approach. Most of the time I think this is easier, but you're welcome to do this when you think it's appropriate. But just a heads up, there are a few questions in our book assignment that this is the only thing that you can do. So when nothing else works, maybe consider taking the log of both sides. Okay, if switching from exponential form to logarithmic form sometimes is all we have to do, occasionally going the other direction from logarithmic form to exponential form is all that you need to do. So in this one, if you switch the forms, you would know what x equals. Switch the forms, you've got x equals. By the way, where's this e coming from? Right, remember natural log just means log base e. So if you need to rewrite that, then you can. That's where the e is coming from. Switch the forms to exponential form, and then this one takes one more step. Switch the forms. If you've got x equals, then that is good. Now, I know I'm skipping over the switch in forms part just because we've done that recently. But of course, if that is a weakness of yours, you'll just need to speak up when we get to some practice questions. You need to make sure that you can do that. That's by far the most common thing we're going to do. Switch from exponential to logarithmic or logarithmic to exponential. Okay, anything jumping out at y'all yet about the first 15 on the notes? We're still okay? Okay, so now we're going to take it one step more difficult. So 16 and 19 are in logarithmic form, 18 and 17 are in exponential form, and what we just talked about was switching the forms is a good way to solve. So if I was to switch the forms on number 16, it would look like this. On number 18, it would be logarithmic form, or 17. Number 18 would look like this. And number 19 would look like that. Now, in the first three I gave to you, that was all you had to do, or first 7, however you want to count them. Why are these not finished? Right, it's not solved for x equals yet, but the hard part's behind it. Switching the forms is still the bulk of the work. We still need to undo some basic algebra here, or some basic arithmetic. We need to undo a -1 with a +1, undo a ×2 with a divide 2. We just have to finish the question by using our normal algebra stuff. Undo a ×3 with a divide 3, undo a ×1 with the divide 1, and what would x equal on 19? On number 19, yeah. What's the answer to 19? What is 10 squared?
Oh shoot, I didn't see that.
You've got it on your paper. Undo this makes it what? What? 93. Y'all could not make that any harder. 100 minus 7. Okay, but with those 4 questions, I want you to see, sometimes when you're willing to switch the forms, it may not be finished. You might need to undo some subtracting, some adding, some multiplying, undo some dividing. If you don't have it in x equals yet, then you need to go there. Now, just like you might need to undo some basic algebra to finish the question, you might need it to also start the question. 20 through 23 are not set up in a form where they are ready to switch. They're not in the right structure yet. So in number 20, you need to undo the plus 9 first. Then you can switch the forms. Number 21, you can undo the times 2 before you switch the forms. 22, undo the plus 5. Before you switch the forms. And 23, undo times 7 with divide 7. So this makes this a 1 before you switch the forms. So some of that arithmetic needs to be peeled away to make it look a certain way before you can switch the forms. Always undo the add, subtract, multiply, or divide. Undo as much of that as you can before you start. Okay, and for this question type, the only way that it can be more difficult is if you have to undo some of that arithmetic at the start and end of the question. So what would we need to do to start number 24?
Divided by 2.
Okay, divide both sides by 2. Okay, now it looks a certain way, so we can switch the form. It's in the right structure. Tack on log, switch these two, puts it in logarithmic form. And then somebody else, what would be our last step? Okay, divide both sides by 3. And then you've got it down to x equals, bless you. So now it's been solved. Okay, so that's about as difficult as it can be. Undo some arithmetic to start off, switch the form, and then if you still have some arithmetic to undo, then go ahead and do it. Same with 25. You could undo times 4 so that it looks a certain way. Now that it's in that structure, we could switch the forms, and then finally undo times 5 with divide 5. Now, just so you guys know on this, I'm kind of skimming over this because we've talked about it a little bit, but if you leave this log base e, that's fine. Log base e means the same thing as natural log. It's just that everyone in mathematics always changes it to natural log, so if you guys don't make a habit out of that, you'll look kind of silly someday. So it's not wrong. I wouldn't count off points on a quiz or anything, but if you check in the back of the book, it's never going to say log base e. It's just going to say natural log. Okay, and then a couple more random things in here. So on the back page, what we did in section 3.3 is talk about how to expand and condense logarithms. So that was pretty straightforward, but sometimes that's your only option to move forward. So question 26, if we think about what we did on the front page here, we did some where we could just do in our head. I certainly can't do this in my head. We did some where we just switched the forms. This does not fit exponential form or logarithmic form, so I can't do that. We had some questions where we had to undo some arithmetic before we could switch the forms or after we could switch the forms. None of that stuff applies. The only way to move forward on these type of questions is to expand or condense. So this is log base 2 and this is log base 2, and they are separated with addition. How did we condense those? Okay, it changes to multiplication. So x times 5 is 5x. And if you consider expanding or condensing, now it's the same as the other side. Now you can switch the forms and finish solving for x. But on questions like these, you can't do anything to move forward to get started without expanding or condensing. So there is only two ways to condense. Addition condenses to multiplication, and then subtraction condenses to, what was the other one? Division. That's the only two ways to condense. So you might have to do that before you can switch the forms and then finish solving for x. 3 times 7 to the 7th. I don't expect 7 to the 7th would be a really big number, so without a calculator we just leave that alone. Okay, in 28, if I condense these two, what would this say on the left side?
Natural log of 7.
Okay, multiply. Addition condenses into multiply, and then that's really the only thing extra that you need for these question types. Logarithmic form, his exponential form, undo times 7 with divide 7. And 29, I don't know why 29's on there. It just doesn't fit this. It's not the same type of question, so you can scratch that one out. So this isn't going to happen often, but there will be a few questions in our book assignment and a question or two on our next test, quiz test, where if you don't consider expanding or condensing to start off, then you're just going to be stuck at the very beginning. Okay, back from section 3.2, we did solve a couple of equation types. We didn't get into all of these other types just yet, but those from 3.2 are still going to be fair game. So this is log base 2 of some stuff, and this is log base 2 of some stuff. We just need to make sure that the insides are also equal. So set the insides equal to each other, and then plug it in to make sure that it's not extraneous. The other question type we saw in 3.2 was simplifying some of this with log properties. So what does all of this come out to be on 31?
8.
8. So if you know that property, you're basically finished. So I'm not going to dwell on those too much, but those are still fair game in this section. We've done those recently. All right, finally, the last of the question types that you need to consider when you get to stuff. So I have all this typed in on the bottom of the back page in the order that I would consider them, but mentally this is what you need to be training yourself to do. Just like on our notes, the first few questions, can we do it in our head? This one, certainly not. Can we just switch the form? It's not in the right format. Can we undo, add, subtract, multiply, or divide? Not really, not and be helpful. Can we expand or condense? No, it doesn't make sense here. So none of those other things are going to be helpful, but when it's got 3 terms like this, you need to consider factoring it. Factoring is the only way to move forward here. Now, if you need to slow down and use a procedure from Algebra 2 or do the product sum method like we talked about earlier this year, then please do. If you can get it with guess and check, that's great too. But you must know how to factor. E to the x times e to the x gives me e to the 2x. Negative 4 times negative 1 gives me positive 4. And my outer and inner combine to be minus 5 e to the x. That's how I know that works. Then just like when you did this in Algebra 2, you could set this equal to 0 and solve. Set this equal to 0 and solve. Switch the forms for one answer. Switch the forms for another answer. But why should we maybe not call this natural log of 1? What would be better than that? 0. E to the 0 is what gives you 1. But the main thing is when you see a question that looks like this and none of the other strategies apply, you need to try to factor it. That's the only way to get going on it. Alright, so there's a quick sample of all of the things that we need to practice and consider as we move through here. Before we slide over to the book assignment and start to practice some of this, I want to show you one quick example of a real life type of question, and I want to show you how to check your answers because that's going to be important in this section. not just relying on the back of the book for checking answers. Okay, so in section 3.2, we talked about compounding continuously. So that was the PERT formula. And so however much you started with was the principal. E we talked about was a number, not a variable. The rate needs to be entered in as a decimal. And now what's different is in 3.2, our last section, we would tell you how many years, and you would either circle this as your answer choice on multiple choice, or you would type in the number, you type all this in your calculator and get your answer. What's different is now we know the ending amount, and we're interested in how much time does that take for that to happen. Now, even though this is supposed to model a real world question here, like buying a car, of course, you know, if you knew within a few days of how long it would take, that's probably sufficient. You probably don't need to know down to the exact second of how long you would have to wait. But if you guys pursue a career in math or science, you get a degree in that kind of stuff, someone hires you, they're going to expect you to be as efficient as possible because that ends up being a lot of money. So this is what we've talked about how to solve on this worksheet. So how could we start to solve this one? Okay, undo some arithmetic if you can. This is optional, but I'm going to switch these two because I think it makes it easier for you to see. What did I do in practically every one of the questions on our worksheet today? Change. Okay, switch the form. And then sometimes we still needed to undo some more arithmetic. So in the end, your exact answer oh, I wrote this down wrong though. It's supposed to be O2. The exact amount of time you would have to wait for your $2,000 to become $6,000 would be the natural log of 3 divided by 0.02. So again, maybe not as relevant for the buying a car example, but still could be important to y'all someday. Now, unfortunately, that as a decimal is about 55 years. So if this is your plan for your first car, you might need to figure something else out. You're probably not going to just wait for that $2,000 to become $6,000. You might need to be adding to that, I bet. I mean, yeah, if you're fine waiting 55 years, that's great.
I can buy a bike.
That's true. Okay, so one thing that's going to happen in this section is, one, you're going to get answers that look unfamiliar. You know, most of the time in math, you do a question, it's usually a nice whole number, which gives you some confidence if it looks like it works out nicely. But in these type of questions, they tend to not work out nicely. The other thing is, and this is the big one, you can do a question right, and your answer can be correct, and your answer could look different than the back of the book looks. Especially on questions like these. Like I took the natural log of both sides, but I could have taken the regular log, the common log of both sides. Instead of doing the common log of both sides here, I could have done the natural log of both sides. It's going to change the way your answer looks, but not make it incorrect. So here's how you need to, well, on the odd questions, I still think you should check your answers in the back of the book. But when your answer doesn't look the same, this is what you need to do. You need to take your answer, and this is why a calculator is necessary today. Store it in for a variable. So the same store button I've told you about a few times this year, right above on. Now, I tend to just store things in for X because this button gives me X right away. But since this is supposed to be T, or time for that formula, you might want to do alpha 4, and you can actually store it in for T. And if it's correct, it's supposed to make that equation true. It's supposed to make 2000 e to the 0.02 times t. It's supposed to equal what?
That L in
6,000.
It's supposed to be 6,000. So if your answer is correct, no matter how crazy it looks, no matter if it looks different than the back of the book or the solution videos on my website, if it makes the equation true, you can still be confident in it. Now, that's unfortunate for me because when we get to your next test, there'll be some answers that are more common, but if you have a different looking answer, I will have to investigate, and I'll basically do the same thing. Store your answer in the calculator and see if it works to know if I can give you full credit or not. Yeah.
Sorry, what's the arrow button again?
It's right here above on. The STO is for store. Just runs out of space. So that's a good one to practice today. Okay, all of this is summarized again at the bottom here. So from the first questions that we did in our head to the last question where we saw factoring, checking to make sure our answer is not extraneous, storing our answer in the calculator to see if it works. So this is kind of a quick little summary of the things that we kind of worked our way through. So now on your blank piece of paper, if you go ahead and copy down that full assignment there. It is a longer assignment, so we'll need to spend the rest of class getting as much of that done as we can. What? The test is not next period, no. We will not finish this book assignment today. I will give you some more time on Wednesday to finish it, but I need y'all to get as much done as you can so that you can easily finish on Wednesday with a practice quiz that I will hand out to you. So for now, I'll give you about 10 minutes. I'd like you to copy that down to your piece of paper, please, and then start the first few questions to make sure it's going okay, and then I'll come in and help out with the ones you're unsure of. Bless you. And the first set of questions should be much quicker, so please don't spend more than like 1 minute on a question. If you're not sure, circle it, be ready to ask about it, and then move on. Don't spend a lot of time there.
Where'd Thompson go?
I don't know. He's not here today. He's out sick.
That's about it.
Say your name is Coleman. Let me check this book out too, so you can take one home.
This is the one that you can take home. You don't need to bring it back and forth because we've got some different fitters you can use. You might want to put in the have y'all done any logarithms where you came from? No? Okay. Well, just do your best and we'll figure it out from there. I don't. How big is it?
Would these work? I'm asking. We're just going.
Pick up the roof.
You usually get hiccups if I do code zero.
Can you start with
I'm not.
I know, but that was like, I asked you to do that like 3 minutes ago. Here's the thing about this right now. So this website is my class website, and I have lots of videos and stuff worked out. So sometimes, like, if we don't finish something, then you need help with a certain question, I might have like a 2 or 3 minute video that worked out already. So the other ones you don't really need to worry about the one, but that one might be one that you want to use. Okay, about 4 more minutes, and you should know on the first couple if you need help with them or not. That will be 10 minutes since I asked you to start.
You okay?
Yeah, I'm good.
You're like wincing.
second divide, the number E.
Yes. Oh, yeah. Thank you, sir.
Yes, sir.
For three, for three, can I just like list down the ones that are correct?
Sure. I mean, it's basically just asking you for yes or no,
Okay.
if it is a solution or not a solution. Okay, so it has already been 10 minutes, so you should have had that assignment copied down, and maybe the first few. So question 1, the vocab question was a little bit of some properties. Number 2 was looking for a word solution that does not satisfy the original equation. Number 3 was asking you to not solve, but plug in a couple answers to see if they worked. And then 7 through 16, I'm sure you didn't get through all of those yet, but those are all starting to solve equations, and they look like those are all about one-step problems. So, which of those questions, 1 through 16, did you have time to try and want me to go over with you? Any of those that you found to be harder than the others or not know what they were looking for? Yeah.
You should be 6.
Number 6? I can, but 6 is not one of the questions.
I don't know. Okay.
Yeah, 6 is a little bit messier, but same idea as question 3. So, are you okay with question 3?
Yeah.
Okay. Anybody else for the first few? Okay. Then I will give you another 10 minutes and then I'll check in again, see how it's going. Again, these first few should be pretty quick. So 1 through 17, the ones that you have to do. Don't, if you're not sure about something, circle it, move on, but don't waste a lot of time there. Just I'd rather you ask. Now, one more piece of advice that I'll give to you. I've said this quite a few times this year, but as you guys are working through this assignment, if there's a property you didn't remember, if there was a mistake you made, if there was something you needed a hint on, anything like that, I strongly, strongly advise you to write that out to the side for that question, or circle it, or highlight it, or do something, because we will not get to this quiz/test before spring break, which means we have to do it after spring break. So we wouldn't do that to you the first day that we come back, but we'll probably have one review day and then quiz. So I suspect most of you guys are not going to want to think about logarithms over spring break. So that means that if you document well what you're doing here, the mistakes you didn't make, the things you didn't think of, you're going to give yourself a little bit of a cheat sheet to hit the ground running after spring break. And if you don't do that, you're going to have to kind of start back at square one. So, yeah.
Are we having more lessons before the test?
This is the last section. Does that answer your question? Yeah.
What are we gonna do?
Well, right now you need to worry about this. Huh? Number 20? Yeah. Alright, guys, y'all do not need to finish this, but you probably should get through at least number 38.
38.
Yeah, there.
I can't even count that high. That's wild, Mr. Townsend.
You'll be fine.
Fun. You know what's fun? Blockus. Blockus.
You said number 20, right? Okay. So the thing you need to notice about question 20, this is going back to like number 1A. If the base and the base are already equal, then you really just need to make sure that the exponents are equal.
Oh, yeah. Crap, we did that today and I didn't remember.
Okay, this is a quadratic, so how do we go about solving a quadratic? Put it all on one side, set equal to 0. Most of the time, if you want to solve a quadratic, you're going to try to do what? Factor. Unfortunately, that one does not factor. We can try all day, it doesn't factor. What's the only other way to always solve a quadratic? Quadratic formula. So this will come up in a couple questions today. But this is about as easy as it gets for quadratic formula. Opposite of b plus or minus b squared minus 4 times a times c all over 2 times a. And the discriminant comes out to be 5, so there's your two solutions. So you're not going to have to do a ton of quadratic formula stuff, but I know that there's at least 2 questions on the assignment, this being one of them. So if a quadratic does not factor, solve by factoring, then unfortunately you do have to do quadratic formula for a second. Okay, can I take another question or two from the beginning? Nothing past 20. Most people are not to question 20 yet. Yes, yeah. Number 12. Okay, honestly, I think the best thing that you guys can do is to, well, try not to look at your notes every single question, but think about the format of the notes. I put them in that order for a reason. The first type of question we looked at, we could do in our head. Can we do this in our head? Diego, I'm asking you. This is your question. Can you do this in your head? No. Then the next thing we talked about was switching forms. This is exponential form, so what would his logarithmic form look like?
Natural log e x
Natural log e
of x
Excuse me,
equals natural log of 1/3.
Okay. So you're taking the natural log of all sides. That's okay if you want to do that. I was going to just switch it from logarithmic to exponential. I think that's easier. But what you're doing is going to be okay too. How can you simplify this?
1 times x.
Alright, the x can come down times 1. And you see how you get the same thing either way? But consider switching the forms. In fact, 7 through 16, I think almost all of those can be solved if you just switch them from exponential form to logarithmic form or logarithmic to exponential. Okay, try to do a few more, please. Again, if you didn't hear me say this earlier today, we're not going to try to finish this book assignment, it's too much. And I'm not even asking you to do it for homework between now and Wednesday. But we need to get as much done as we can so that we can finish it on Wednesday plus the practice quiz. Okay, just a few more minutes, and then I'll take a couple questions. I said a few more minutes, and then I'll take a few questions.
Say you were hoping we get that 36 today.
No, I said you need to get as far as you can. If you don't get to at least like question 38, then you probably need to do a few for homework.
Okay, that's.
But as long as you get to at least that, then you can, you should be on track to be able to finish on Wednesday.
Which was Mr. Thompson.
I'm looking at the calculus notes for my class tomorrow,
That's fine.
making sure I remember how to do this.
Guess what problem I'm on?
Number 28.
36.
That's what I meant to say.
Oh, yeah. Very funny.
But have you been checking your answers?
Yeah. Totally.
Okay, well, you might have some stuff to redo then.
Probably. I actually work in 100% accuracy.
How do you know if you're not checking your answers?
It's like statistically speaking, I just don't get things wrong. Just don't look at my grades. You ready?
Okay. So it's been roughly 10 minutes here. So I don't know. Questions 1 through, I don't think most people are up to question 36 yet, but any questions you tried 1 through 36 that you know you want some help on? Okay, that's fine. We can look at 38. Now, if you have not made it to 38, you might want to jump ahead. If someone else is asking about this, you might need help too. Or I should have it worked out on the website if you want to keep going with what you're at. Now, this one is a very good question to ask because this is kind of a slightly different question. If I think at our notes, I certainly can't do this in my head. It's not the right structure to switch the forms, There's not any arithmetic that I can undo. I can't expand or condense. It doesn't factor. So the only other thing that really showed up on our notes, I told you that there were a few questions where you had no choice but to take the log of both sides. So that's probably the least common strategy to use, but when nothing else works, that's a good one to try. And the reason why we would want to do that is because then this is an exponent on something you're taking the log of, so this stuff can come down out front. The natural log of e is just 1, because this is saying e to what power gives you e. Over here, this stuff is an exponent on something that I'm taking the log of, so it can come down out front. And then this is just a number, so we can distribute it. And then anytime you're trying to solve for x, you need to move all the x stuff on one side, move all the constant stuff over on the other side. But here's the other thing that I'm concerned about. If this said 8x minus 6x, you would quickly tell me that that simplifies to 2x. But this is 1x minus a natural log of 2x. So how can we move forward with this?
Can you divide stuff? No.
You can divide in a second, but you need to do something else first. This is one of the easiest algebra things for y'all to do, but it's not always easy to see that you need to do it. Huh? Very good. Both of them have an x, so you can factor it out. As I've mentioned many times this year, I know you can all factor out GCF, but it's a whole nother thing to be able to do it without the hint that that's how to move forward. Then you can undo times with divide. Now, like I was saying in our notes here, this is a pretty wild looking answer. So, well, first off, this is an even answer, so it's not going to be in the back of the book. But if I store this in my calculator, this is 38. Okay, so you can see I stored it in my calculator. So my calculator knows when I type in x, it's using this exact value, it's not rounded. It's supposed to make the left side equal to the right side. Now, it doesn't matter what the left side's equal to or what the right side's equal to, but it matters that the left side equals the right side. So since that's true, you can have full confidence in your answer, even though it does not look like it could possibly be correct. It is perfectly fine. But the really special thing about this question was that very first step. You almost never have to take the log of both sides to start the question, but this is one of those questions where nothing else works. So do it as a last resort. Okay, other questions before 38? Because 38 is pretty far into the assignment. 28?
I haven't tried it myself yet.
Okay, well, we can talk about it together and I can fill in the gaps then. What would you try to do to start this off? What's the most common strategy that we used on the notes? Okay, so this is exponential form. Logarithmic form would look like this. Is that closer to getting your answer?
Yeah, I think I was just,
Yeah.
I was just overthinking it.
To me, this looks like this is definitely a step in the right direction. You should undo -3 with the +3, and then undo it -1 by multiplying both sides by -1. And then you know what x equals, so that should be your answer. Switch the forms, undo the arithmetic. Undo the -3, and then undo the times -1.
What's there a buddy on your payment?
Hmm?
There's a buddy on your payment.
Yep. Okay, let's set one more timer. We got about 20 minutes, so I'll give you one more chance to ask some more questions here in about 10 minutes. So try to get a few more finished. Try to find one or two more I can help you with.
factored this, how is those two multiplied to get to 2x really squared?
Well, it's not x times x, you get x squared. It's u to the x times u to the x. What is... What's x times x?
X squared.
Because when you multiply things with the same base, you add the exponents. So e to the x times e to the x, you're gonna add the exponents. That's why it becomes e to the 2x.
Gotcha. That makes sense.
Yes, ma'am.
Did I do that right?
Divide both sides by 500. Yeah, that'd be a fourth. Right here. Okay, so I'm good with you dividing both sides by 500.
Mm-hmm.
So that's going to give you e to the negative 2x equals 1/4.
Mm-hmm.
But you changed it to natural log. It should just be an e right now.
Oh, okay.
Now maybe the next step, you could switch the forms, which would make it natural log of 1/4, or that,
Mhm.
equal to this. Okay, yeah, now it looks okay.
Okay.
Good.
Thank you.
Okay, just a few more minutes, and I'll give you one more chance to ask a few more questions before y'all leave.
Bless you. Need a tissue? Okay, it's been 10 more minutes, so let me try one last time. Christian, can you just worry about your work? So,
Alright, one more chance. Again, just as far as the ones you've tried, what do you got?
number 40.
Number 40.
You need number 40. Oh, just.
Okay, so mentally for question 40, I'm thinking of all the stuff in the notes. I certainly can't do this in my head. I can't just switch forms. It doesn't need to be factored. There's not logarithms to expand or condense. So what did I say maybe was the very last thing to consider trying?
I forgot the log of both sides.
You could take the log of both sides. It doesn't have to be natural log, but in calculus we always use natural log, so that's a good one to use. And the reason why you might want to do that is because now this is an exponent on something you're taking the log of. So from our exponent or logarithm properties, that can come down out front. Same with this, it can come down out front. So we've got a number of x squareds. I could distribute this. That's just a number. I've got some x's. So because this is a quadratic, what should we do next? You cannot factor it like this.
Oh, switch forms.
Quadratics, you want all on one side. Set equal to 0. And then you normally solve quadratics how? Okay, does this look like it's going to factor though?
No.
No, that's pretty crazy looking. So if it doesn't factor, what's our only other option? So A is going to be what?
X squared ln3.
Okay, but it's how many x squared you have. So A would just be the coefficient of x squared. B is just the coefficient of x, don't include x. And C is the constant. And while that looks terrible, and of course we don't want to use quadratic formula if we don't have to, it actually is not too bad, assuming you know quadratic formula. Because you're going to plug in the opposite of B once. You're going to plug in b squared minus 4. Then you're going to plug in a. Then you're going to plug in c. Now I'm going to multiply the minus 4 and the minus 6 to make it plus 24. That's pretty much the only combining I can do. All over 2 times a. Oops. And even though that's super messy, there's really nothing you can do from there. So I just plug this in everywhere the quadratic formula said to put a, plug this in everywhere the quadratic formula said to say b, and plug this in everywhere the quadratic formula had a c. And then the only thing I could simplify was a negative 4 times a negative 6 becomes a positive 24. So it's not nearly as difficult as it looks. But you got to know that first step. Again, it doesn't happen often, but some questions like this one, the only way to start is to take the log of both sides so you can bring those exponents down. Okay, Diego, you had another one?
20.
Did we not do 20 already? Yeah, we already did 20. That's fine. You can get it off the website now, or from the class recording. Okay, so I want to say this again to be clear. I do not expect you to finish the bookwork in class. I do not expect you to do it for homework. The only exception is if this is just harder than a normal assignment for you, you might put a little bit of time in for homework. I would say at least get through question 38. Wednesday, I've got a 1-page practice quiz I want you to try to help you catch what's working and what's not working. And I will expect you to finish this in class. So if you're not near 38, then you need to do some homework to catch up with everybody else. But we've only got a few minutes left, so if you borrowed one of my calculators, please bring that back. And then find a stopping place.